At this point, we've explored two server-side technologies for helping clients configure themselves. Now it's time to explore the client side directly. In this chapter, we're going to jump into Ribbon and understand what client-side load balancing is all about. At the end of this module, you'll be able to understand the purpose of client-side load balancing, and you'll be able to use Spring Cloud Ribbon to implement the client-side load balancing. So first, let's begin by defining some terms about load balancing and client-side load balancing. Traditionally, a load balancer is a component that sits in front of an application, usually a web server, and it has the purpose of distributing load. So let's say we have a single application, a web application, that's getting bogged down under consumer load. We could put an HTTP load balancer in front of it. Add two more servers, or dozens, or even hundreds. The load balancer simply dispatches the incoming request to one of the real servers, usually using some simple algorithm like round robin. It doesn't do any actual processing. Load balancers have been with us for years and are not new. They may be implemented via software, or often organizations will purchase special hardware applications to make the load balancing super fast and reliable. What you see here is a traditional server-side load balancer. Now, a client-side load balancer is part of the client application software, and its purpose is to select which server to call. There may be, and probably should be, multiple copies of the server application that the client can call. The client-side load balancer makes itself aware of what servers are available and makes its own choice about which one it should call at any given time. It makes a decision based on some criteria, perhaps something as simple as round robin, but as we'll see later, it can get very sophisticated here, perhaps keeping track of which server is giving it the fastest response. We'll also see how it becomes aware of what servers are available, but I'm betting you can guess how this works already based on what we just went through on Eureka. Of course, the servers themselves can employ server-side load balancing, as you see here, and the result is a very resilient solution. Now, you may be wondering why this is necessary since we have server-side load balancers, and they work great. And truthfully, depending on your application's needs, you may not need client-side load balancing. But this capability does allow you to enjoy a level of resilience and adaptability that is often needed in a microservice architecture. Simply put, not all servers are the same. I can have servers that crash unexpectedly. Has this ever happened to you? And I could have the load balancer itself become unavailable. I could have some servers unexpectedly slow down, making other alternatives more appealing. So look at this diagram here. Here I have an application running in a region, and I'm referring to AWS regions in this example. I expect that the application can make a call to a server in the same region because it's fast, but what if it is somehow unavailable? If my client-side load balancer is aware of other regions, it can route the call to the other region. Even though the call may be a bit slower, the application stays running. So now that we understand what the client-side load balancing is for, let's explore Spring Cloud Netflix Ribbon. The Ribbon project is another part of the Netflix OSS family. It is battle-tested by Netflix and is being used extensively even as you watch this presentation. It is a client-side load balancer, and it has automatic integration with Eureka Service Discovery. It also has support for failure resiliency, which we will cover later when we get to Hystrix, and it even supports things like caching and batching. Caching is when you let the client avoid the remote call entirely because it has saved results of a similar recent call. And batching is when several requests are grouped together into one call, which is generally more efficient. I won't cover these here, but you can certainly explore these capabilities on your own if they're interesting to you. Now, one interesting thing about Ribbon is that it supports multiple protocols, not just HTTP. In this course, you'll only see me demonstrate HTTP, but this is a nice capability to keep in mind. Now, Ribbon is part of Netflix OSS. Spring Cloud merely provides an easy-to-use wrapper around Ribbon, so it's easy to use with a bare minimum of code and configuration. Before we jump into the code examples, we should take a moment to explore some key Ribbon concepts, starting with the list of servers. In Ribbon, and in regard to a specific kind of service being called, there is a concept of a list or a pool of possible servers. This list can be obtained from a static source, like you see here at the bottom of the page, or more likely for us, from a service discovery mechanism like Eureka. Spring Cloud will assume you are using Eureka when Eureka is present on the class path, otherwise it will be expecting something else. If we have multiple kinds of services that we intend to call, it is important to realize that there is a separate list of servers for each kind. So if I want to call a joke of the day service, there would be a list of servers for this. If I want to call a word of the day server, there would be a separate list of servers for this. Now, somewhat confusingly, the servers that we are calling here are identified by their client IDs, which only makes sense when you consider that these apps reported themselves to Eureka as clients. Now, in this example, stores and products are client IDs, even though each represents a list of servers that we want to call. And this is an example of static lists. Next, given a list of servers for a client, a filtered list attempts to select a favored subset of servers for use by the load balancer. In Ribbon, there are a number of strategies that can be used. In Spring Cloud, the default strategy is to include only servers in the same zone. Now, how a zone is determined will be discussed later. Next, ping refers to the strategy that Ribbon client will employ if and when it wants to perform a health check on the target server to see if it's really up or really down. Again, there are several strategies to choose from in Ribbon. When using Spring Cloud, the default setup is simply to defer to Eureka to make that determination. And this is a good, safe strategy, except it isn't foolproof. If you have done any experimenting with the last exercise, you've probably discovered some corner cases where a client goes down and Eureka has not discovered this yet, because there is a little bit of a delay between the time that Eureka stops receiving a ping and has decided to exclude that client from its list. And by the way, if you want to override any of these defaults that I'm going through, it's possible and easy, and we'll cover it in a bit. Next, we have the load balancer itself. The load balancer chooses a server from the filtered list, usually by deferring to a rule component that makes the actual decision. In Spring Cloud, the default load balancer is something called a zone-aware load balancer, which is, again, bringing up this concept of zone, which I'll get into in just a bit. Lastly, a rule is the single component responsible for making the server selection. There are several implementations available. Spring Cloud's default is something called the zone avoidance rule. Okay, so enough background. Let's see some actual code. Using Ribbon in your Spring Boot projects is really easy. From a Spring Boot project, you can either switch to the boot parent to the cloud parent, being careful to adjust the version to the latest stable version of Spring Cloud. But as I've mentioned before, I expect that it will be more common to add a dependency management section, as you see here at the bottom of the page. This allows you to keep whatever parent your project is currently using. Again, this should look very familiar. This is essentially the same series of steps and choices that we would take for a client to use Spring Cloud Config Server or Spring Cloud Eureka. Also similar to what we've seen before, we need to add a Spring Cloud starter for Ribbon. This will bring in all of the Spring Cloud and Netflix open source software jars that we need to take advantage of Ribbon. Again, this is all client side. There is no server side configuration with Ribbon. There is no Ribbon server. The closest thing conceptually to a Ribbon server would be the Eureka server, as this is the component that is going to supply us with the list of clients. Now, with the dependencies all set up, all one needs to do is access the Ribbon load balancer in the code and use it. Important note here is that this is a demonstration of low-level code. This is probably not something that you would want to emulate because in a later section I'm going to show you about Feign and Hystrix, and that will supplant some of what you're seeing here. But for the time being, let's explore this code. The AutoWire of the load balancer client gives us the Ribbon load balancer. Now when we use it, notice that we need to supply a string to the choose method. This is the client ID discussed earlier. So this is identifying something that we get from Eureka or something from our static list. We are asking Ribbon to select a server for us. Within this code, we don't know or care how it makes its determination. We just expect it to return us a server to call. From there, we just extract the URI and give it a call. The thing I found most confusing about this is that the key subject, the documentation calls it a client ID, but again, it's really a type of a server. The best way to think of this is that when all of the servers register with Eureka, they are all clients, and Eureka has given Ribbon a list of these client IDs. Now the code you just saw is 100% legitimate, but it is not the most ideal because it couples our code to the Ribbon API. As Spring developers, we don't like to be coupled to any API like that. So in the next sections, we will introduce a declarative approach that will avoid this completely using feign and hystrix. Now, before we get into the lab, I just want to satisfy some curiosity that you may have about customization. All of the defaults I mentioned previously can be overridden. Basically, you define a bean of the same type, and Spring Cloud will defer to your bean instead of the one it wanted to put in by default. But there is a little bit of a trick to this. Remember what I said just a few moments ago about each client or server gets its own set of load balancers, rules, and server lists. You may want to customize these different breeds of servers differently. So what you do is you create a configuration class specific to each one. Then, separately, you use the ribbon client annotation in your main configuration class to point to each one that you've customized. All of the ribbon clients will use the defaults except the specific clients that you've specified. Now, the real tricky bit is that you do not want to component scan the class that you see here. If you do, it will be picked up by all of the different clients, which might not be what you want. Again, this is a little confusing, so you might want to review the reference documentation on this point. Now, when it comes to all of the different options for server lists, load balancers, rules, pings, it would take too long to explore all of them, so I'll refer you to the Java docs or the GitHub code itself on the Ribbon project. You can learn all about the different options that you have. Suffice it to say that the defaults selected by Spring Cloud will get you up and running quickly and will probably work just fine in the majority of cases. So to summarize, client-side load balancing augments regular server-side load balancing by allowing the client to select a server based on some criteria. And Spring Cloud Ribbon is an easy-to-use implementation of client-side load balancing. And now it's time for the lab. In this lab, you will take a copy of the code you completed in the last lab, the one that assembled a sentence from the different words, and you will refactor the code that makes the call to obtain the words. If you didn't finish the last exercise, don't worry. The starting project files for this lab are essentially the solution to the last lab. So give it a try.